Hey, good evening. This is Mr. Kaczynski. I'm going to take a few minutes here to go through our quiz 4-1 over the first three sections of chapter 4 and give you all the solutions to these so you can do your corrections. Here we go. All right, so first of all, we're asked to sketch a graph of each of these situations. So a function. Okay, so I went ahead and drew a line. And really, you could have drawn anything that will pass the vertical line test. And we'll get more into what the vertical line test is here later on. But I think you guys know how to use it. So anything that passes the vertical line test, anything that doesn't overlap itself. And for a graph of a relation that is not function, you could have drawn anything that doesn't pass the vertical line test. So that's pretty much it. I saw a lot of different crazy answers. We didn't have too much issue with it. I don't think anybody got those wrong, as a matter of fact. Moving on. Okay, tell whether each relation in the form input-output represents a function and explain how you know. Did give a lot of half credit on things like this. First of all, person and their social security number. So this is a function, and the idea is that every person has one social security number. Some people said that it's that everyone has a different social security number. That's not what it's about. My wife and I could have the same social security number. Well, we can't, but even if we did have the same social security number, that wouldn't make this not a function. Because again, it's about the fact that we both have one social security number. It does not matter if two people share the same social security number. So it has nothing to do with the fact that they're different. First name, last name. This is not a function. The explanation on this is that two people with the same name, same first name, can have different last names. So every person named Corey, their last name isn't Kaczynski. In fact, there's two teachers in this building. There's another teacher in this building with the same first name as me who does not have my last name. So two people with the same first name can have different last names. Again, some people had some errors in their explanations. What about city and zip code? Well, this was straight off our homework. This is not a function because a city can have more than one zip code. So Lake Orion, for instance, has two zip codes. So therefore, this is not a function because every input has to have exactly one output. In Lake Orion's case, there's two outputs. And what about state and governor? This is a function. Again, it's not because every state has a different governor. Okay, even if Rick Snyder was the governor of Michigan and the governor of Ohio at the same time, that wouldn't make this not a function. This is a function because every state has one governor. Every state has one governor, not that every state has different governors. All right, we had major problems here with filling out this table, and it starts right with the first one. Negative 3 squared, guys, is not negative 9. Negative 3 times negative 3 is positive 9, and positive 9 minus 3 is 6. A lot of negative 12s right there. Negative 2 squared is 4. Any number times itself is going to be positive, whether it starts out negative or positive. So negative 2 times negative 2 is 4. 4 minus 3 is 1. Negative 1 times negative 1 is 1, and 1 minus 3 is 2. 0 squared is 0. 0 minus 3 is negative 3. 1 squared is 1, minus 3 is negative 2. 2 squared is 4, minus 3 is 1. And 3 squared is 9, minus 3 is 6. You can see this symmetry here around the 0, the input 0. So use the values in the table to sketch a graph of the equation. I didn't mark many people right on this because your sketches were very difficult to read. This also says use the values in the table. So I'm actually supposed to plot these 7 points. So that's what I've done here. Here's this point 0, negative 3. I got 1, negative 2, and negative 1, negative 2. I've got 2, 1, and negative 2, 1. And I've got 3, 6, and negative 3, 6. So we should get this kind of figure here. What about, is this equation representing a function? Well, it's absolutely a function because every input has exactly one output. It doesn't matter that negative 3 and positive 3 have the same output. They can share the same output. It just matters that every time I put -3 into this equation, I always get 6 out. Every time I put -2 into this equation, I always get 1 out. Also, you can see on the graph that it passes the vertical line test. And that gets us to our next question after this one. What about the domain? Or if the domain is -3 to 3, which it was right here, -3 up to 3. What's the range? Well, the range at the bottom is -3. That's the smallest it gets in between these x values. And the biggest it gets is 6. So anywhere between -3 and 6, including -3 and 6. That would be the range. All right, so what about this vertical line test that we've been talking about? So a lot of different explanations. I know one thing that we did cover, it's not about drawing one vertical line and looking to see how many crosses the graphs. It's about drawing every possible vertical line on your graph and seeing where it crosses. So here's what I said. Take any object that you can use to represent a vertical line, such as a pencil or ruler or even your finger. Run it from left to right across the graph. If the graph represents a function, it should not cross this vertical line more than once at any given time. And the key thing is here, this at any given time. Some people just said draw a vertical line, and I circled the word A because it's not about drawing a vertical line, it's drawing every possible vertical line. So we don't actually draw it. What we do is use an object or just even our imagination and run it across the graph. Does a vertical line represent a function? Well, this almost seems silly at this point because a vertical line does not represent a function. First of all, it obviously wouldn't pass the vertical line test. If you put a vertical line on a vertical line, it's going to intersect it more than once. Some people worded it like this, that one input, there's only one possible input for a vertical line, would have an infinite number of outputs. And that's true. I definitely saw some very confusing answers on that. When people start talking backwards about outputs before they talk about inputs, it gets very confusing. Makes an algebra teacher's head want to explode. But this is the simplest way to put it, that one input would have an infinite number of outputs, or more than one. All right, so a lot of errors on this. I know we talked about this in class. There was a problem in the homework that had a bunch of points, and we were supposed to list the domain and the range. And I remember saying that, look, guys, it's not continuous. This is discrete. So you can't just say it's this range of numbers. You have to say that it is these numbers exactly. So a list of numbers. So first of all, is this a function? So I see 4 here and 4 here, and that's okay as long as I get the same output every time. When I inputted 4 here, I got 1, but when I input 4 here, I got 0. That means that this is not a function. The input 4 has 2 different outputs, 1 and 0. So usually when we're listing the domain and range, we go from least to greatest. So the domain is our inputs. I see -2, 0, 3, and 4. We don't need to list 4 more than once. And for the range, that's the outputs, the y values. Again, I'm going to list those in order. -1, which I don't need to list more than once, 0, 1, and 3. So what about b? Is this a function? This is a function, and it does not matter that the inputs -3 and 0 have the same output. It does not matter that -3 and 0 both give me an output of 3. That does not affect whether it's an output or not. I've talked about that on several occasions now through this video. So the domain, the possible inputs, -3, -1, 0, 1, and 5. I'm putting those in numerical order. Didn't mark it wrong if you didn't, but it would have made my life a lot easier had everyone done that. And the outputs, or the range, is, there's only 4 of them, 0, 2, 3, which occurs more than once, but we don't need to write it more than once, and 8. All right, a lot of issues with this one. We're trying to write a story to fit this graph about Sarah's dog Chico resting on the front lawn. So that's where we're going to start right there. Sarah's dog Chico was resting on the front lawn. Okay, so what happens here? You got to identify, guys, that our independent variable is time and our dependent variable is speed. A lot of people forgot to do that. Independent is time, dependent is speed. So what happened here? I'm going to say that He's rushed on the front lawn when he saw the mailman and quickly accelerated to catch him. So he quickly built up his speed. And then what happened here? Chico maintained his top speed for a while, chasing after the mailman. So the mailman's driving down the street, and he's chasing after him. He was not rusting here. This is a measurement of speed. This is also not a measurement of height. Some people thought it was a measurement of height. It's a measurement of speed. So he's reached his top speed, and he's maintaining that until he gives up his chase because maybe he got tired, and he slows quickly at first. And then he kind of breaks into a trot and then into a walk. So something about the fact that his speed decreases by decreasing amounts, or it decreases quickly at first and then more slowly and then slowly. Then we get to this situation here. So what's going on here? Again, remember, we're talking about speed. Sarah calls for Chico, and he quickly ran towards her. And here it's not about the fact that he's running a different direction. He could still be running the same direction. We don't really know. But here it's about the fact that then he slowed down. So he accelerated and then slowed down as he got closer to her. And then lastly, Chico resumes his nap on the front lawn. Sketch a graph of a function that fits this description. There's really only there's a finite number of answers here. Continuous and always increasing with a slower and slower rate of change. Okay. So continuous, it's increasing, but that increase is getting slower and slower and slower as we move to the right. It's got to look something like that. Linear, that means a straight line. Discrete, that means not continuous. And decreasing is something like this. So it's got to be discrete. That's why the dots. Okay, there's nothing in between there. Linear, it's in a straight line. Decreasing, as x gets bigger, y is getting smaller. And lastly, identify the independent and dependent variables in each relationship and justify your choices. So we got the relationship between the number of minutes spent on a long distance call and the cost of the call. I'm going to say, and I really think there's only one possible answer for this one, that the number of minutes spent on the call is the independent. That's the thing that you can change. The dependent is the cost, because the cost of the call depends on the number of minutes you talk. So this sentence is really what I was looking for in people's answers. And then the independent and dependent variables should be listed. And if you wrote this sentence, this has to be the possible answer. So what about the relationship between the amount of flour used for a cookie recipe and the number of cookies you make? Well, one might say that the amount of flour used is the independent variable and the number of cookies made is the dependent. And if you said that, then you'd have to justify it by saying this. The number of cookies made depends on the amount of flour you used. Okay, so given a certain amount of flour, you can only make so many cookies. If you have less flour, you can make less cookies. More flour, you can make more cookies. My answer key, I actually went with this choice, that the independent was the number of cookies and the dependent was the amount of flour. And I defended it by saying the amount of flour used is dependent on the number of cookies you want to make. So once I decide how many cookies I'm going to make, that will determine the amount of flour that I need to buy and then use in my recipe. So I would have accepted either one of these as long as you have the right justification and then the corresponding correct independent and dependent variables. So I went very quickly through this because there's a lot of writing. Hopefully on any problems that you needed more explanation on, that you paused the video so you could write down the answer, or you replayed it so you could hear my explanation a second time. Hopefully this is helpful to you, and good luck getting your corrections done. Have a great night, and I'll see you soon.